Oh, okay, okay. I mute just now. I speak alone. So saya ulang balik sebab tadi saya termute. Okay, so these are the topic that you are going to learn tonight, which is scheduling. So scheduling, if in Malay, it is called as penjadualan, in which that if a product need to be produced or to be completed, so it has to go the step or the flow. It has the flow in which okay, this flow first you do this, and then the second one is to do this. So it must be according to the step. Okay, so it cannot go from A to C and then suddenly go to Y, and then suddenly finish to Z. That's something like that. So this is what you will learn this tonight, because in order to optimize the process, you have to sort it. Also, you also will learn this one, FCFS, EDD, SPT, LPT. FCFS is first come, first serve. EDD is EDD, I cannot remember lah. SPT is short processing time. LPT is I think late processing time or long processing time. And then you also learn Johnson rule. Kejap Okay, so the the planning, the production of our factory, okay, should be based on the demand. So let's say the demand this month, for example, is higher, so you need to speed up the process or increase the number of labor, for example, in order to meet the demand. Okay, to meet the demand. So and then from the demand, we will come out with MPS and also the MRP as well. So this is a scheduling lah. Scheduling is where each activity it is. I simplify it as a flow. It's a flow in which that in that flow you must have the specific activity in order to complete the the cycle of the production. Okay. So terms in scheduling, we have routing. Routing is the sequence lah, the sequence order flow. The sequence which one to be done first. This is the route. So for example, if the product require two route, for example from A it has to go to B, and then also at the same time it has to go to C. So at one point this flow will meet up and then finally will be assembled together to finish the product. For example, in the production of car, okay, we want, for example, we go to Proton. The final product is the whole body of the car, but we cannot do the process one by one. We will do it concurrently. Okay, we call it routing. So for example, the tire we do it at another factory. The interior part we do it at the factory, but then when each of this part is completed, we bring it to one factory and then assemble it together to meet. They will meet up at some point. Okay. Then we have bottleneck. Bottleneck is a resource whose capacity is less than the demand placed on it. Whose capacity is less than the demand placed on it. A resource whose capacity is less than the demand placed on it. Okay, actually this bottleneck comes from the word of bottle and also neck. Bottle and also neck. So if you see bottle, this is bottle. So this is bottleneck, this area. Okay. So if you look, if you go, for example, if you go to Kuala Lumpur from Kuantan, KL from Kuantan, you after reaching, let's say this is LPT, this is LPT, this is Gombak, to Gombak, and then after reaching the Tol Gombak, after passing through the Tol Gombak, you will go to MRR. So this is MRR. So this MRR, you have one junction, and also you have one junction to another direction. Okay, so this is called as bottleneck. Bottleneck is the place where the stream meet up. So if you let's say you upside down this bottle, it will become like this. And then the water, if there is water inside the bottle, so the bottle when you make it upside down like this, the water will try to come out as soon as possible. However, because of the bottle area is this big, and then the area of the neck is this big, the water in here will compete to each other, to go out, causing congestion. Faham tak? Causing congestion, kesesakan. So similarly, here, if there are many other junction wanted to join the MRR, it will cause congestion. It will cause kesesakan. Okay, we call it this bottleneck. Bottleneck ni adalah satu area yang mana when many other activity meet up at one point, it will cause congestion. So similarly in industry, if we have we call it conveyor. If we have conveyor, and then this conveyor stream like this from here to here, but here suddenly there is one junction, so another part comes to here, and another part also join at here. So this area will become the bottleneck, in which that this conveyor will become congestion. So the operator who works here will be facing a lot of pressure, because there are lots of incoming materials coming towards that operator. Faham tak? Itu masuk bottleneck. Bottleneck ni adalah satu area yang mana bila berjumpanya proses-proses ni, dia akan menyebabkan berlaku kesesakan kat situ. Itu maksud dia, resource capacity is less than the demand placed on it. And the due date is the date when the job is supposed to be finished. Select the time that a job can be delayed and still finished by its due date. Okay, something that we can delay that, but we can still finish it by the date it's required. For example, you have an assignment to be submitted next week, but you did not do it now, because you know that process can be done the next day, because you know it can be completed by the time it is needed. Okay, that is slack. Q is a waiting line. So this is the objective in scheduling to meet customer due date. All that to minimize job lateness, untuk mengurangkan kelambatan pekerjaan, to minimize response time, minimize time. Okay, everything. So I think we just go to the main point of the chapter. So this intermediate high volume system, high volume is the process where you do it in mass production. For example, you do it a lot of all. Then intermediate is average, and then low volume is low quantity production lah, low quantity production. Okay. shop floor control, loading, sequencing, monitoring. Okay, so for example, now you want to, let's say you are working as a manager or as an engineer. As an engineer, you have a task, okay, like this. As an example, you have four worker. You have four worker in which his name is Brian, Kari, and third is Noah, and fourth is Chris. You have four worker and you also have a project. So you want to assign, like for example, Brian to do which project, Kari to do which project. So each project has to have one worker. So, but you don't know, you want to assign Brian to which project, you want to assign Kari to which project. Okay, but this is the data lah. For example, kita baca dulu Webstar Incorporation has 4 web project. So this company is doing website. Okay, to complete and 4 worker with varying degrees of expertise in web development for particular industry. Estimate processing time in hours for each project by worker are shown below. So this is 10. 10 means 10 hours. 6 means 6 hours. 7 means 7 hours. For example, Brian, if he do project 1, he can complete it in 10 hours. If Kari do project 1, he can complete it in 6 hours. And so on lah. And if Brian do the project 2, he can do it in 5 hours. If Kari do in project 2, he can finish it in 2 hours, for example. Okay. So this is the data. And then development time cost an average 100 an hour. 100 an hour. So for example, for Brian, if he do project 1, he can complete it in 10 hours. So the cost will be 10 times 100, which is 1,000 ringgit. So the higher the cost, the more that you don't want it. You want to reduce it because the objective is to minimize the cost. Okay, the objective is to minimize the cost. So how should we do this scheduling? How should we schedule this? Which person to do which project? Okay, so the step is like this. First you do this, and then you do this, and then finish. So this step is shown in the example lah. So this is what we are going to learn today. So this is the summary of the step, and how you do it is like this. First is row reduction. Row reduction, you subtract minimum value in each row from all other row value. So you row reduction, find the best assignment in each row, subtract the smallest value in each row from all other row value. For example, row Brian. So Brian, initially you have Okay, so for Brian, for example, you have 10, 5, 6, 10. So the smallest one is 5. The smallest one is 5. The smaller one is 5. So from this instruction, subtract minimum value in each row from all other row value. So 10 minus 5, 10 minus 5 is equal to 5. 5 minus 5 is equal to 0. 6 minus 5 is equal to 1. 10 minus 5 is equal to 5. Faham tak? So you get this one. 5, 0, 1, 5. So similarly, carry 6, 2, 4, 6. So the smallest one is 2. 6 minus 2 is equal to 4. 2 minus 2 is equal to 0. 4 minus 2 is equal to 2. 6 minus 2 is equal to 4. Faham tak? So you got 4, 0, 2, 4. And then Noah, the smallest one is 5. So 7 minus 5 is equal to 2. 6 minus 2 is equal to 6 minus 5 equal to 1. 5 minus 5 equal to 0. 6 minus 5 equal to 1. So you get this one. Okay, similarly for Chris. Okay, and then you do column reduction. So you got all this value, and then you find this one. For example, 5, 4, 2, 5. The smallest one is 2. So 5 minus 2 equal to 3. 4 minus 2 equal to 2. 2 minus 2 equal to 0. 5 minus 2 equal to 3. So you got this one. Faham tak? Similarly, for this one, 0, 0, 1, 1. The smallest one is 0. 0 minus 0 equal to 0. 0 minus 0 equal to 0. 1 minus 0 equal to 1. Okay, you got 1. So you got this one. Faham So sama ini. And then third, look for unique assignment as examine the metric and cover all zeros. So you cover this 0. And also you cover this one. So you got like this. Okay, you got like this 0, and then you got this one, and then you got this one. Okay, modify the metric, find the smallest value of the entries that are not highlighted. So this one is not highlighted. Okay, find the smallest value. The smallest value that is not highlighted is 2. This one, right? 2. So subtract the value from all other non-highlighted entries. So 3 minus 2 equal to 1. 2 minus 2 equal to 0. 3 minus 2 equal to 1. So you got this one. 1, 0, 1. 1, 1 is 0. And then 4 minus 2 equal to 2. 3 minus 2 equal to 1. You got 2 and 1 here. 5 minus 2 equal to 3. So you got 3 here. Faham tak? And then look for unit assignment. Assign each worker to the best project available. Brian is assigned to project 2. The project 2 eliminated. So from this, Brian, the 0 is here. So he got project 2. Kari, the 0 is, because Brian already got project 2, Kari cannot have this project 2 anymore because, so he have to project 1. Faham tak? Noah, because Kari already got project 1, he cannot get project 1. He must have project 4. So Chris must have project 3. Faham tak? So yang ni, dan yang ni. Faham tak? So, and then the calculate performance at the cost of 100 an hour, the project will cost, ambil balik yang awal-awal tadi, 5, yang the question, 5, 6, 6, 4. So you add all this and then you time by 100 and you get 2,100 to complete the project. Faham tak? Okay, tak faham tanya Okay, and then as example 2, similar thing. First, you do raw reduction. Raw reduction, the smallest one is 6. So 11 minus 6 equal to 5. 14 minus 6 equal to 8. 6 minus 6 equal to 0. This one, the smallest is 8. 8 minus 8 equal to 0. 10 minus 8 equal to 2. This one, minus 8 equal to 3. So similar to this one. And then you do the column pula. Okay, you do column. 5 minus 0 equal to 5. 0 minus 0 equal to 0. 2 minus 0 equal to 2. So you get this one. 8 to 5. The smallest one is 2. So 8 minus 2 equal to 6. You got 6. 2 minus 2 equal to 0. 5 minus 2 equal to 3. Faham tak? And then this one, 0 to 0, the smallest one is 0. 0 minus 0 equal to 0. 3 minus 0 equal to 3. 0 sama dengan kosong. So you dapat this one. Okay, and then you cover all that 0. So this you cover all the 0, you get this one. And then from here, you find this one, this one, this one, this one. Which one is the smallest? So the smallest one is 2. So 5 minus 2 equal to 3. 2 minus 2 equal to 0. 6 minus 2 equal to 4. 3 minus 2 equal to 1. So you got 3, 0, 4, 1. You got 3, 0, 4, 1. Okay? And then you start assign lah. So R34 is for C. So as this, okay. And then job T50 must go to worker A. Job T50 must go to worker A. Okay, because okay, X66 has have options either A or B. But if you give 66 to A, okay, T50 has no option. Has no option because C already given to 34. So you must give 66 to B. Faham tak? And then T50 get 0. Faham ke? So the original cost is you go back to the original question, which is this one. This one, this one, this one. You add all, and then it will be this value. Tak faham tanya? Okay, and then sequencing and job and one machine. So LCFS is last come first serve. Slack is smallest slack. CR is critical ratio. So this is the what is stand for lah. Okay, so this is example. Apply the 4 popular sequencing rules. First come first serve, short processing time, EDD, LPT. Nanti saya bisa tengok Tengok kat sini je lah. Okay, this is processing time. This is flow time, due date, EDD, late jobness. Okay, we apply the 4, okay. So this is the job. We have 4 job A, job B, job C, sampai job E. And then if you do job A, the number of days that you require is 6. You require 6 days to complete job A. And then the due date, you must complete it within 8 days. That means you can finish the job in 6 days for job A. However, you have been given 8 days. That means you have 2 days extra. So you I think you understand me, right? And then job B, if you do job B, you can finish it in 2 days. And then the due date must be completed in 6 days. So similarly CDE. Okay, ini faham tak? So how you do it? So because the question asks you to do all this, FC, FS, FPT, LPT, so you must do it one by one. First is FCFS. So if you do FCFS, first come, first serve. So first come, first serve means you must do the job A first. Job A first, job B, job C. This is according to the flow lah. First come, first serve. Okay. And then total processing time is 28. Flow time, you add all become 28. And then you add all become 77. And then you add all become 11. So the average completion time is total flow time 77 minus by 5 number of job. You got 15.4 day. And then utilization equal to total processing time over total flow time. 28 over 77, you got 36.4. And then so on lah. Okay. And then you do SPT. This is the second one. Okay, SPT. So SPT, you sort this job sequence. You sort this job sequence based on the processing time. For example, if you look here, the job A requires 6 days, job B requires 2 days. So these two must go up because 2 is less than 6. So you sort this job sequence based on the processing time. So it must go from 2, 3, 6, 8, 9. Okay, ascending. Okay, ascending. So the job sequence is B, D, A, C, E. B, D, A, C, E. So 2, 3, 6, 8, 9. And then the flow time must follow together. Must follow the job sequence. So for example, if job B, the process time is 2, so the flow time also must follow. Okay, so which is 2 lah. 2 and then add with 3. 2 plus 3 equal to 5. 5 plus 6 equal to 11. 11 plus 8 equal to 19. 9 plus 9 equal to 28. Okay. And then due date must follow the same lah. And then let's say job C, the due date is 18. So it must follow. So C is 18, this one must follow. And then job lateness is processing time minus due date. You got 0 lah. Faham tak? Sebab job lateness is completion time tolak due date. This is the equation lah. Lateness equal to completion time minus due date. Okay. This is SPT. And then so you add all, it become 9, and then you put in the equation and then you get all this data. Okay. So now you do number 3. Number 3 is EDD. Okay. So EDD is according to due date. So due date, this one, you sort this job sequence according to the value. So 6 first, 8 become number 2, 15, 18, 23. So when you sort this due date, the job sequence must follow as well. So 6 is actually for B. So you must go back to the original question. So your due date 6 is actually belongs to B. So it must go first. So B become first. because 6 you are going to put on top. And then 8 must go to number 2. And then A become number 2. Okay? And then follow lah. Okay? So after that, you just put in the equation, this equation, where you add all this, and then you put in the equation. Okay? So, and then this one, the first one is LPT, late processing time, which is late job lateness lah. Job lateness. Which mean that you start all this job sequence according to the processing time, but from the biggest time to the smaller. Okay, 9 is the smallest, 9 is the biggest, 8 is the second biggest, 6, 3, 2, and then you add all. Okay, you add all this one, now this one must follow, and then you put in the equation. So you get the summary. So this is the first one, the second one, third, fourth. Okay, this is the summary lah. So this is how you do the sequencing rule according to the FCFS, SPT, ADD, and LPT. Okay. Okay, slack is due date minus to this date minus processing time. But you must do this one first. Due date minus to this date minus processing time. And then critical ratio is time remaining over work remaining, or due date minus to this date over remaining processing time. Okay, so if CR over 1, job is ahead of schedule. If CR below 1, job behind schedule. If CR equal to 1, job is on schedule. Okay, and then Johnson rule. Okay, Johnson rule. Okay, this example first. So let's say we have 3 jobs, A, B, and C. So due date is 30, 28, and 27. Work days remaining 452. So critical ratio is just follow this equation lah. Due date minus due date over remaining processing time. Due date minus due date. Due date is 25. So this is due date. This is the due date. And then over the work days remaining equal to 4. So divide by 4. So you got 1.25. And then you do the B, 28 minus 25, and then divide by 5. So you got this one. You got 0.6. So CR with CR critical ratio is less than 1. Job B is late. Okay. Job C is just on schedule because it's above 3. And this one has No, no, job C is on schedule, and then job A has some slack time. Okay, that this one is Johnson rule. So the objective is to minimize total production time and idle time. So this is how you do the Johnson rule. This is the step lah. First, first you list all jobs and times for each work center, and then choose the job with the shortest activity time. Once a job is scheduled, it is eliminated from the list. Repeat step 2, 3 until all slot in matrix are filled. Okay, this is the example Sekejap Give me 2-3 minutes. Okay. So we have here. First, we read the question. Johnson finds restoration has received a rush order to refinish 5 carousel animal. So carousel is the light cage, carousel cage. Carousel ni is like macam dia punya sangkar, sangkar lah tempat kita nak simpan binatang tu. Okay, yang pertama sangkar untuk alligator, buaya, a bear, cat, deer, and elephant. Okay, gajah. So restoration involve 2 major process. So mempunyai 2 major process. Yang pertama sanding. Sanding ni adalah sanding ni macam guna kertas pasir. You use the sandpaper to what we call to maybe to finish it. Okay, to do some finishing. And then the second one is painting, mengecat. Okay, Mr. Johnson takes care of the sanding. So Mr. Johnson do this job, one job, and then his son does the painting. So and then his son do the painting, mengecat. The time required for each refinishing job differ by the state of disrepair and degree of detail of each animal. So this is sanding. Okay, this is painting. Okay, process 2 is painting. Process 1 is sanding. Okay, and then given the following processing time in hours, this is 6 hours. 11 hours, 7 hours. Okay, determine the order in which the job should be processed so that the rush order can be completed as soon as possible. Okay, what you need to know is process 1 has to be completed first. Then you can do the process 2. If you do process 2 first and then you want to process 1, that cannot be. Okay, you must do process 1 first. Okay, job A, job B, job C, job D, job E. For example, you want to finish job A. A is for alligator. The carousel, you want to do carousel for alligator. You must go to 2 processes, which is process 1 and process 2. But you must do process 1 first. You cannot do process 2. without doing the process 1. Faham tak? Similarly, job B, in order to complete the job B, you must do process 1 first, in which that it takes 11 hours. And then process 2 takes 6 hours. So what you need to know is Mr. Johnson, who do the process 1, must do all the A, B, C, D, E first. Then after he finish all this, he can pass this, he can pass his sending to the process 2, to his son. Faham tak? So how to do it? You have to follow this rule. First, you do list all job and times for each worker. Choose the job with the shortest activity time. If that time is in the first work center, schedule the job first. If it is in the second work center, schedule the job last. So you see this, you find the smallest one, which is 5. So 5 will become the first, which is first, because it has the smallest processing time. And then the second one is 6. 6 is the second smallest, will become the second. So because it is A, so this one is E lah. Okay, and then you take the biggest one. Biggest one is, oh no, if it is in the second work center, if it is in the second work center, schedule job last. So from here, the smallest one is in the second work center, which is process 2. So it must go last, which is this one lah. So this is become a 5. Faham tak? And then 6 is the smallest in the process 2, in the second job center, become B. And 7 become 3. Faham tak ini? Tak faham tanya So, because E is the first, so E is the first lah, this one. So E is the first. So once E is the first, and then this is process 1, which is Johnson, and this is process 2, which is his son. Okay. Process E has to do first, and it requires 5 hours. So you put 5 here, in which that from 0 hours to here require 5 hours. And then after he finish, job E, Mr. Johnson finished job E, he has to pass job E to his son. Okay, he has to pass the job E has to son. So his son has to start the job after receive the job from Johnson. So his son has to start at 5 hours. So in which that from here to here, his son do nothing. His son do nothing because he has to wait his father give the job to him. So which is why this is the idle time. So this is his son idle time for the first 5 hours. So he do nothing. So and then after 5 hours, he receive job from his father. So he do this E for 10 hours. So which 5 plus 10 equal to 15. Okay. And Mr. Johnson continue second job, which is A. After he finish E here, A require 6 hours. So 5 plus 6 equal to 11. And then he continue doing D. D require 9 hours. So 11 plus 9 equal to 20. And then he continue doing B, which is 11. 20 plus 11 equal to 31. And then continue doing C. C is 7. 31 plus 7 equal to 38. Okay, equal to 38. So his son will get A after he finish his E. So 15 plus A here, 8. 15 plus 8 equal to 23. And then 23, for this one D is 7. 23 plus 7 equal to 30. And then from 30 hours, we have one more idle time here, because by the time his son finished D, Mr. Johnson haven't finished B yet, because B only finished at 31, while his son already finished at 30. So his son has to wait until B is finished. Then Mr. Johnson will pass the job B to his son. Faham tak? So which is why that we have 1 hour of idle time here. And then B is continue 6, which is 31. 31 here plus 6 equal to 37. Okay, and then once again, when his son finish job B, he has to wait 1 hour, because his father, Mr. Johnson, did not finish job C yet, because job C only finished when it is 38. So this is 38. Okay, so he has to wait 1 hour. So we have idle time here. And then C is completed at 3 hours. So which is 38 plus 3 equal to 41. Okay, so this is when the job is finished. So we have also idle time here. So Mr. Johnson finished already at 33 and also have idle time of 3 hours here. Okay, so the total completion time is 41 hours. So the ideal time is 5, this one, and then 1 here, and then another 1 here, and another 3 hours here. So this is idle time, 10 hours. Okay, so this is the exercise. Yeah, you can do this exercise according, but just follow the example that I have already explained. Okay, ada soalan tak? Itu sahaja chapter 9. So if you have any question, you can ask now.
Exam nanti masuk topik ni ke doktor?
Test masuk topik ni. Hari tu masa test 1 tu, sekejap kita off record